Welcome everyone, and thank you for joining us today for DigitalGlobe's lead webinar series, Learn, Engage, Act, and Discover. My name is Becky Schneider. I'm the Marketing Programs Manager at DigitalGlobe, and I'm also going to be your host for today's webinar. But before we get started, I want to pass along a few tips and tricks to keep in mind while viewing today's webinar in Adobe Connect. First, all attendees are on mute. So to ask a question to today's presenter, you can type that question in the Q&A chat box that's located at the right-hand side of your screen. We're going to take some time at the end of today's presentation to answer some of the questions that you might have for today's presenter. Attendees have the option to view the webinar in full screen. If you prefer that full screen mode, just click that full screen X that's located at the very top right-hand corner of your screen. And lastly, a link to today's webinar recording will be sent to everyone via email within the next 24 to 48 hours. Today's webinar is titled Precision Ortho Imagery as the Source for Authoritative Airport Mapping. As the aviation industry moves from paper maps and charts to digital cockpits and electronic flight bags, producers of these products need current and accurate data to ensure flight safety. Today's webinar will highlight how to utilize current airport imagery to build digital aviation mapping products and the fundamental value to aviators, integrators, and airport operators. Today's webinar will be presented by CompassData's Vice President, Hayden Howard. In the past decade, Hayden has served as lead surveyor and survey manager on several CompassData projects. With experience in collecting data, training, managing field crews, and managing the collection methodology, as well as managing international data collection and deliverables at every stage. Hayden has personally collected data in multiple countries around the world and has managed the collection, post-processing, and final deliverables of large projects, both domestically and internationally. Hayden is certified by Trimble in GPS data collection and post-processing. Hayden holds a Bachelor's of Science degree in Land Use Management with a GIS Aviation Meteorology concentration from Metro State University in Denver. So without further ado, I would like to welcome Hayden and let's today's webinar.
Excellent. Thank you very much, Becky. Appreciate the opportunity to speak to everybody about the authoritative mapping, authoritative airport mapping projects that we've been working on with DigitalGlobe. Appreciate everybody's time. So just to give a little background on CompassData, we're probably best known for our photo identifiable ground control point archive database. And we've been collecting ground control for about 20 years. And during that time, we've collected many airports for GOI and DigitalGlobe and their end customers. But about 3 years ago, I was working on a project with some DigitalGlobe folks in support of an end customer that needed a authoritative solution for airport mapping. So this kind of got us to a position where we needed to look into what that meant and what a DO-200 certification from the FAA is. And after doing some research and looking at the opportunity, we decided to go for it. And in April of 2014, we received our DO-200 certification, and since then have been going full bore with the aviation data collection and learning a lot about airports and the aviation industry. So just to get us started here, got some very interesting information about air travel. So 1/3 of the world's airports are in the U.S. In the late 1980s, American Airlines saved an estimated $40,000 by giving one less olive in each salad served in first class. Singapore Airlines is the second largest buyer of Dom Perignon champagne in the world. air traffic is estimated to grow 4.6% annually for the next 20 years, and it is impossible to open a plane door in mid-flight. So the last note there really has no relevance to geospatial products or data, but it brought me great comfort to learn that, so I thought I would share it with everyone just in case there was anyone out there that was wondering that same thing. But so how does this relate to the market of aviation, all this information? So if we consider this market that has an annual revenue of $7.5 billion, where you can save $40,000 by providing one less olive on first-class salads on a single airline, with 1/3 of the airports in the U.S., you can start to imagine the impacts and efficiencies we as geospatial professionals can bring to the table. So today I'd like to share with you what CompassData and DigitalGlobe are doing in this market and share some of the products that we're providing that hopefully will be of interest to you folks that are listening. So a brief look at the agenda, go over the aviation products, the FAA certification, the DO-200 from the FAA, the workflow there, and then the benefits of this data to the different market players, so the airport operation, aviators, airport authorities, and really just looking at who the users are currently and what they're doing with the data, an overview of the product, the pedigree of the DO-200 certification, and what that means, the life cycle of how the data is created in that authoritative process, and then kind of touch on some of the obstruction data that we have that is a byproduct of the DO-200 data that we're creating, and look at some of the market-specific benefits. So who are the current users of our airport data? And it's a good question to start with, because the way that we have our unique DO-200 certification approach allows for a lot of different use cases of this data. Our main driver for this right now is the business jet market and data that goes into the cockpit. That's authoritative. But after doing some of this work for a few years, we quickly realized that the data that we're producing has use in airport operations, aviation authorities use this, general aviation, electronic flight bag companies, military flight simulators. So based on how we have the certification set up, which I'll go through here in a minute, there's opportunities for people to leverage just our ground control points that are certified through this process, a certified Ortho, which we would produce with DigitalGlobe's Imagery in our IPP agreement, and vector map, or certified AMDB, and DEMS that can be used for obstruction analysis. So a high-level view of the products that we're offering is the certified authoritative airport image with horizontal accuracy of 85 centimeters. So this is really kind of our uniqueness right here, is that we're providing a certified 2D ortho image over airports at 85 centimeter horizontal accuracy. And that's kind of a combination of the ground control points that we use and the great imagery that we get and have access through our IPP agreement with DigitalGlobe. And what can be done with that is vector mapping of the aerodrome, so that's the airport mapping database, AMDB, to a 1 meter accuracy. So with this high level of accuracy on the airport image at 85 centimeters, that allows the amount of slop that is needed in the digitizing to produce a certified 1 meter AMDB. And as I mentioned earlier, a byproduct of this is the DSM from the stereo imagery, which we'll go into in more detail here shortly. And this can be used for terrain and obstacle databases, which we produce, or we could produce just the DSM and give that to the customers that would want to do the obstacle database themselves. And then we also do insert imagery for in-flight entertainment. So that's something we've worked with DigitalGlobe on with a few customers where they need higher res imagery inserts around the aerodrome and the airports. So you have a 15-meter resolution image when you're flying far away, and then as you come down, you get a refresh and higher res imagery closer to the airport itself. Here's another look at the overview of the products, basically like the key elements that are used to generate this DO200 data. The photo identifiable ground control points that we have around all the aerodromes where we have the certified data. So that's consistent ground control with pictures, station diagrams, network adjustment reports. And then the Ortho and AMDB, which AMDB is that airport mapping database, which is an attribute-rich vector database that can be certified to go into a cockpit or can be used for airport operations on the asset management side, building lease management, security, AVL, vehicle tracking as a base map, and then the airport terrain and obstacle databases. So that, again, is the byproduct of the DSM that we're generating and using the control very highly accurate and can be used to do obstruction analysis. So the DO200 certification, what is this? It's a certification from the FAA, and there's about 30 of these DO200 certifications globally. Now, of these 30 certifications, there's about 15 companies that hold them. So these are companies and organizations like Jeppesen, Honeywell, GE, NGA. A division of the FAA itself has one of these certifications. So it's a very small group of companies or organizations that have this certification, and it's very similar to an ISO certification where you have lots of documents, lots of procedures, lots of QA checks, audits, training manuals, and it's a big undertaking. So the key thing probably about this DO200 certification for some folks on the line here that are from different countries outside the U.S. is that there's airport authorities that recognize these DO200 certifications like ICOA, NGA, EASA, Eurocontrol. It's all referenced in their certification documents, and they work closely with the local certifications to align with DO200 on the FAA side with the other certifications in different countries. So kind of the ugly portion of this, at least on my side, is all the documentation that was associated with making this jump into the certified world. So there's 434 documents that are associated with this. These are check sheets, spreadsheets, training slides, videos and tests, quality records, corrective action reports, the audit reports that we have, configuration management, tool qualification. It's a big deal, and as it should be, because the data that is being produced is ending up into a cockpit in most cases and is used for safety critical navigation. So our certification is, as I said, unique in that we kind of set up with the survey side being the thing that is testing everything, right? So we go out to an airport, we collect photo identifiable ground control points, we do the directional pictures, station diagrams, we do the post-processing, the QA, QC, delivery of the GCPs and the data, the metadata associated with it, and then we repeat that for the checkpoints that are used for the accuracy verification. So, and as you go down this flow chart here, right in the middle, survey planning, survey check, and GCP post-processing, GCP archive, GCP delivery, these are all certified processes that are the sole responsibility of CompassData. And then the way we have our certifications is the image provider could be somebody else. In 90% of the cases for us and our customers, we are producing the imagery right here. We are the imagery provider, but this is not a certified process based on the emphasis on the ground control and the checkpoints and the accuracy verification piece being certified. So really the imagery can come from anywhere, but in most cases it's CompassData using 30 or 50 centimeter resolution imagery from DigitalGlobe to produce the high accuracy orthos. And then we take those orthos, whether it be from us or from a different provider, and we run it through our qualified tool, which is Accuracy Analyst, qualified by the FAA to generate reports on the accuracy of that image and stamp it basically, and it's ready to go into the extraction process, which we can do with partners, or if companies out there already have that capability, you can leverage the DO200 imagery that we have in our database, which is accurate to 85 centimeters horizontal. Okay, so to jump into the first part, the survey of the ground control points, right? So we are using GNSS data receivers, GPS. We go out to locations around an airport and survey photo identifiable points. I'm guessing most everyone knows what that is, but I'll explain it anyways. It's point high contrast, as you can see right here where this red arrow is pointing over on the image. It's that concrete corner that you can identify that individual pixel very clearly where it comes up against the dark grass, dark asphalt to generate a very fine point. So we set up on features that are already out there that are photo identifiable, distributed around the airport, and we take pictures and station diagrams and do this in a very consistent manner, and then we take all that data and then we get the information on the GPS used back in office, and then we do the post-processing and network adjustment. So this is really what we can hang our hat on here. This is why we have the certification, is because of our geodetic expertise and the way we document it and the way we prove that the accuracy of the ground control points and the checkpoints is sufficient enough to do the testing of the ortho imagery accuracy. So this is just an example here of the post-processing that is done. So you have base stations, and then you have your ground control points located around the airport, and then you do network adjustments, and it generates all these reports, ellipse errors, and adjustment statistics, and all this information is documented and associated with the GCPs that is delivered. This is all part of our DO200 process to ensure that we produce geodetically sound data. So another key piece to this process is that we are global with this product, and we can't go everywhere ourselves, so we often leverage our partners around the globe to do the data collection for us. So for places like Egypt, Saudi Arabia, maybe places in South America, India, with our 20 years of experience in the ground control world, we have these partners, which we call control freaks, and they follow a very stringent process to collect the data. They send us the raw data, and we do all the post-processing in-house to make sure that it's geodetically sound and it's in the right epic and data and coordinate system according to our customers' data quality requirements. So the next step is the image ortho rectification, DSM and DTM generation. So using the high quality imagery through our DigitalGlobe IPP partnership, we are able to get stereo imagery, and we take the stereo imagery, we use the ground control points, we generate a DSM, a digital model, and then we take that digital surface model, and we clean up all the obstructions, the buildings, the trees, and create a DTM, a digital terrain model, or bare earth. And then we take the most nadir of those two stereo images and place it on there with the control points that we've collected, and then we use those to generate a very accurate ortho image. A key thing to this process is when we go out and we survey, we survey enough points, more than we need, photo identifiable, that can be used again and again and again. So if we have an airport and there's some kind of maintenance updates from 6 months ago or 3 weeks ago or 2 years ago, we don't have to redeploy the surveyors to go out and collect more ground control. We leverage the control that we already have in-house, and then we get new imagery through DigitalGlobe, and we create a new certified image. The next step is the accuracy verification. So again, this is using our qualified tool from the FAA, Compass Accuracy Analyst. And what you're seeing here is you have the point, the photo identifiable coordinate, which is this red dot right here, and then you have the ortho image coordinate, which is the feature itself, the pixel where that point should be. And then within our software, you basically load the imagery, you load the checkpoints, and then you go into the software and you say, okay, here's actually the pixel where that point is, and it calculates the delta on that individual point. And then you have enough of these individual points, and it statistically calculates the overall accuracy of the ortho image. So here's another image, basically of the interface of that software, where you can see there are multiple control points, X, Y, and then you have the image-derived locations, X2, Y2, and then you can get the delta, and you get circular error plots, and you set the threshold based on the customer's data quality requirements. In the cases for us, it's 85 centimeters horizontal accuracy, and then you run the statistics on it, and then it kicks out a final report, which looks something like this on the left here, right, where you have the overview of the image, just like a clip of where the image is, a picture of the ground control point that was surveyed, a combined statistical analysis of all the individual points and the deltas between where their actual location is compared to the image ortho location, and it generates this report that is all certified by our processes and our qualified tool from the FAA to state the accuracy of that ortho image. So this results in a 30 to 50 centimeter resolution ortho image with 85 centimeters accuracy in the horizontal. This is basically the data that is provided to most customers right now. It's certified, it's 85 centimeters, and it's ready for our customers that want to do the element extraction for the AMDB. Key, I guess, is that the 85 centimeter horizontal accuracy means that in any pixel, if you zoom in on this image or any of the images that we have in our database of 500 airports, and you click on a pixel, you know that that is going to be the absolute spatial accuracy within 85 centimeters or better of that location, which enables the digitization of vector data that can be generated to a 1 meter accuracy level. So the fine level of accuracy suitable for use in the aviation industry and safety critical navigation. And here is an example of the AMDB that's generated, Airport Mapping Database, certified to 1 meter accuracy. And this is the DO272 AMDB and the data elements. So all these elements, the runway intersection, runway markings, taxiway shoulders, touchdown liftoff areas, these are all the locations or the attributes that are extracted from that ortho image and are certified and have the correct attribution for getting put into the cockpit of a plane and doing navigation based on that. Now, there is definitely value to this data on the airport operations side, not just in cockpit, and we'll go over that in a minute, but you could imagine the asset management that you could do, the pavement asset management and buildings, and just understanding what kind of assets you have on your individual airport or your group of airports as a GIS base map, and then having this for several airports in a consistent manner that is very accurate to within 1 meter based on satellite imagery. Okay, so as a byproduct of that ortho image that we have our certification, our main customers right now are ordering from us. We have the DSM, and this DSM is very accurate based on the same procedures using ground control points and checkpoints and stereo imagery from DigitalGlobe, and we can create airport terrain and obstacle databases. So this is an example of an Area 2C and 2D that is Annex 15 compliant, ICAO. And let's see, I'll go to the next slide here. Basically, for those that are on the webinar that don't know, you have a surface that comes off of the runway and it protrudes out, and then you have these accurate surface models, right? And then what you can do is you can say, okay, based on this requirement, here's what the surface should be, the flight surface, and then you take the surface model, and then you can see the penetrating areas, and then you can create this obstacle database. As you can see here, there's these big blocks, the purple, the brown, and these are big areas where there's a lot of features that are obstructing that surface, and they can be blocked into one, or you can get the individual points where it might be just a tree that's not surrounding any other points that are penetrating that surface. So I think in my next image here, better view of that. So yeah, just another view here, basically generating the DSM and then also the DTM, and then bringing in the surface, the obstruction surface, and then getting the penetrating features, and then generating the obstruction database based on the features that are penetrating that surface. And again, same thing here. Some obstacles can be grouped as one, such as neighborhoods, houses, in areas where there's enough of these penetrating surfaces that are close to each other, and they get blocked, and then they all get associated with the feature that penetrates that surface to the highest level. So in our database of the 500 airports that we currently have, we have data that looks like this. So a DSM at 1.5 meter post spacing, and then you got the 3D view of that. So it kind of shows you basically the 3D digital surface model that's generated from the DigitalGlobe satellite image, 1.5 meter post spacing, and then the DTM of that same area at a 5 meter post spacing. So basically you can tell by looking at the image on the top left, you can see all the buildings, all the trees, the vegetation. And if you look at the image on the bottom, that's the same airport with all that obstruction, things above the ground that are not bare earth removed. So our database, so this right here is our ground control point base, approximately 42,000 photo identifiable ground control points off the shelf and growing. So the reason for the approximately is because we have field crews out every day collecting more ground control points, and we have people in here that are post-processing that and then putting it into our database. So it's growing every day and updated online you can get to this database in a truncated format, and it's 40,000 points. So not all of these points are collected for airports, but as you can see here, there's about 7,000 DO200 GCPs that we have in our archive that cover over 1,000 airports with accuracies of better than 20 centimeters X, Y, and Z. In most cases, the accuracy of these points are much better than that, but based on our data quality requirements for this certified product, 20 centimeters is sufficient, especially because we're using satellite imagery that has a resolution of 30 to 50 centimeters ground sample distance, so 20 centimeters or better is what suffices to generate that product, that ortho rectified image that has a horizontal accuracy of 85 centimeters. So as you look at the bottom here, you can kind of see some of the locations that we have just zoomed in. So Honolulu, 20, 11 points, Cape Town, 12, Sri Lanka, Tokyo, a lot of different locations around the globe where we have physically been there, surveyed ground control points to that DO200 process, and doing network adjustments and getting all the documentation in place for the DO200 process so that it can be used for this safety critical data that gets put into a cockpit. Another thing to be noted here is that although not all of these are around airports, many of them are DO200 because we follow the same process, so we can do things like certify elevation data sets around a country based on this DO200 data. And here you see our airport database. This is also available online. If you go to our website, you can download a KMZ or a shapefile, and it just indicates the distribution of our locations, and it gives you a thumbnail. You click on it, you'd see the image, the date of the image, and the accuracy of the image. So what you're seeing here is the blue is in our database, and the red, we have the DO200 GCPs that cover that airport in-house. So all we need to do is take imagery from the DigitalGlobe database, the archive via our IP agreement, and generate these certified ortho imagery. So a lot of coverage in the U.S., Western Europe, Africa, Asia, and growing daily as we're out collecting more airports for our current customers. So, and every single one of these has a DSM DTM associated with it based on the satellite stereo imagery that we're using. So our main driver for this product and getting the certification and going down this path is the business jet market. But as I said earlier, there's a lot of benefits that can be seen on the airport operations side. So several of our individual airport customers that are using this data are leveraging it across many divisions. So noise mapping, AGIS compliant databases, for those of you that are familiar with that, that's the FAA Airport GIS program. Wildlife mitigation mapping through the USDA, they use it as a base map as they go out and they map the activity of wildlife around airports. It can be used to reduce the cost of construction on the airport design side, asset management, maintenance tracking, work orders, inspection, building space management is a really big one. Our customers on the airport, individual airport side are using this for what buildings do they have, what are the tenants, what's available for lease. The finance and accounting departments are using this vehicle tracking base map. So if you have a very accurate vector data set and image of your airport and you're tracking your operational vehicles around there, you can do such things as geofencing in your AVL, your vehicle tracking software that says, once a snowplow is going into this runway, I want you to alert me, alert the driver, so it's used as a base map there. So probably the coolest thing about the satellite approach to this is it It's providing about 90% of the data needed to increase operation efficiencies and cost 20% of the additional AGIS survey, like the 18B FAA cost. So when you look at what is being done for the traditional way and using aerial imagery and using traditional survey, you do get more data, but on the airport operation side, in order to get some return on investment, if you have this AMDB GIS layer that's very accurate and can be updated based on just new images and not having to go resurvey, you can do a lot of great things operationally at your airport with that data for much less than it would cost to get an aerial provider out there. And with 30 centimeter resolution satellite imagery, we're just really getting to that point where we're bumping up against some of the aerial costing and capabilities of the end data that is coming out of that. And benefits for the aviators, so really looking at our current customer base, which is the avionics integrators that are taking this and generating a DO200 AMDB that goes into a cockpit. It's that 1 meter accuracy that is really a big difference maker. A lot of people in the space that are doing these AMDBs do it to a 5 meter level accuracy, where this 1 meter you can do safety critical navigation, and that accuracy equals time savings. So if you're a pilot in a business jet and you have a 1 meter map in front of you in your cockpit and it's really foggy, you can navigate based on that 1 meter map, where if it's a 5 meter map within there, you might be limited on where you can navigate based on your visual capabilities with heavy fog. So situational awareness, doing things like digital NOTAMs based on an accurate base map is very beneficial for the aviators. And then the maintenance updates, as things change at the airfield, getting a quick update based on satellite imagery and not doing a whole aerial acquisition and resurvey. That quick update with accurate information is definitely a benefit. So really the takeaways I would hope everybody gets from this is that with our DO200 certification, our agreement with DigitalGlobe and accessing the imagery, we can provide different ways to get to this data. We can provide just the GCPs if some of you in the audience are doing the ortho rectification. Maybe you don't necessarily need a certified data set, you just need an accurate image. We can do the certification of your imagery if you want to send us just the imagery. We can do the GCPs, the ortho, and then produce the certified ortho and give that to somebody who's ready to do the element extraction, or we can do from the GCP collection all the way to the end AMDB that's certified via our partners that we work with in this space. So it's a foundation for the avionics market to build upon. That is an 85 centimeter foundation that enables a 1 meter end product, which is very unique, and it's a global product where we leverage our field guys that are around the globe, get the data in-house, and then we can continue to produce this certified ortho almost anywhere in the globe. I shouldn't really say global because there's certain countries that we can't go into, at least not yet, to do our traditional survey, but it's very few far between, like China, North Korea, Cuba, and then some that we could go to, but it's kind of cost per head based on the costs for security but yeah, basically a lot of reach, a lot of stuff in our database already, and a lot of ability to go out and get more areas. So the database is off the shelf. There's 500 with another 500 that are ready to be produced, and it's a licensed data model, which is what allows us to create this database. So as we go out and collect this data for other people, you can leverage the database based on the fact that we license the data. And then we are positioned to provide certification for other aviation-related products based on existing procedures. So this is really looking at the way we set this up with certified ground control, the accuracy and geodetic expertise that we have there, and then taking in any input data and certifying the accuracy of that to produce an authoritative data set that can be put into a cockpit. So with that, I believe I am ready for some questions if anybody has any.
So thank you again, Hayden. That was a wonderful and very informative presentation. As Hayden mentioned, at this time we're now going to open up the Q&A portion for today's webinar. So if you have a question for Hayden, please type that into the chat box feature and we'll answer them in the order that they're received. Thank you again, Hayden. That was wonderful. I did have some questions that came in while you were presenting, and it's kind of a two-part question. One of the listeners wanted to know, what's the biggest advantage of using satellite imagery? And the second part of that question is wanting to know, is there any disadvantages in your perspective?
Okay, yeah, that's an excellent question. By using satellite imagery, we're really bringing the cost down compared to the traditional aerial collection. With that said, the disadvantage would be slight in that the resolution, although 30 centimeters is very high resolution and it's great, you can extract a lot of elements from that. There still are some elements that might not be able to be extracted based on not being able to see them in the imagery itself, whereas with aerial imagery, you might be able to pick up the smaller lights around the aerodrome. But yeah, the advantage is the access to this imagery, the fact that it can be collected quite easily and quickly as opposed to aerial, and then the disadvantage would probably be that the features that you can extract from it are slightly limited compared to the features you can extract from higher res aerial imagery.
Thank you. Moving on, another question that came in, a listener was curious to know, how long does it take to process a single airport?
Yes, great question. If we already have the ground control points in-house and the imagery is in the database and accessible for us, it takes between 1 and 3 weeks right now. So if we do not have the GCPs in-house and we have to go capture it, it could be, just really depends, I guess. Like if it's somewhere that's hard to get to, like Egypt right now, that could take a little bit longer, and you know, maybe a couple months or something. But if it's an area where we have access to the airport, or maybe an airport authority locally that is interested in this data can support us in getting access, it's a matter of getting our field guys to the field to survey the GCPs, and then once we get those in-house, which could take up to a week, I would say. It's just the process of getting the recent imagery from DigitalGlobe and then doing our procedures and add another 1, 2 to 3 weeks in there, so between 1 and 4 weeks.
That same listener had another follow-up question, and they wanted to know, if they already have their GCPs, can they send them to you to create this project for them versus having to wait for GCPs if it's coming from an area that's harder to obtain this information?
Yeah, that's a really good question. We could certainly use the GCPs from the end customer, but if it's a certified product that they're looking for, then we might be able to use them, but we would need all the raw data, and it would have to be collected such that we can use it in our DO200 process. So for a certified data set, it would just be on a case-by-case basis depending on how the GCPs were collected and if we can get to the raw data. And then if it's a non-authoritative image that they're looking for, then yes, absolutely, we could use the GCPs that are provided by the customer.
Moving on, another question that came in, a listener would like to know, with many airports that are changing due to construction or remodeling because they're older airports, do you have a process of updating some of these airports that you've already collected when the construction is being done at the airport?
Yeah, great question. And with us having our main customer in the business jet market, that's certainly something that we have to have in place. So the way we set it up with our customers is based on their requirements, and we set up kind of like a point system. So we say, okay, if nothing's changed at the airport in a year, you get a point, and then if they change one building in there, that's worth 3 points. And then if they put an entirely new runway in there, that's worth 10 points, which triggers an update on it. So it's something that we do have on some of our airports. You'll see in our database we have 3, 4, 5 ortho images over a single airport that are certified based on these airports that are changing a lot. And then to do it with the specific customer's requirements, we just need to have that conversation and see how updated they need it, and kind of understand that we're limited on the imagery acquisition based on things like clouds and availability. So I hope that answers the question. Yes, we do, and have different ways to set that up based on what our customers' needs are.
Moving on to your next question, Alyssa wanted to know, do all the airports that you currently have in your database, do they cover the same area? And I think what they're talking about in terms of the size of the location as far as square kilometers.
Yeah, that's another really good question. When we started doing this, it was based on a per square kilometer price for imagery. So some of them will be much smaller, and then as the IPP agreement kind of came into place, we were able to grab up to 400 square kilometers around an aerodrome. And so it's a mixed bag, but we do have a KML, KMZ that identifies the areas that we have, the size of the areas around every aerodrome. And then if it was something new moving forward, we could do up to 400 square kilometers around an aerodrome based on our current IPP process with DigitalGlobe.
So we're going to take a couple more questions before we close out today's webinar. Hayden, your next question is, a listener wanted to know if CompassData has ever uploaded one of your satellite-based airport products into the FAA's AGIS portal.
Yep, another very good question, and we have done that with several airports. It's a bit of a different process, and we've worked closely with the FAA and DC on how that works. And the exciting thing is that since it's a certified data set through a different division of the FAA that does the DO-200 certification, they accept that we're uploading into the AGIS. And again, it's just a slightly different process in which it gets uploaded. But yes, we have uploaded data from a satellite-based acquisition that's DO-200 certified into the AGIS.
And your final question for today's webinar is, a listener would like to know what type of airports are in your database. So they're curious to know, is it just large international airports, or are you also working on smaller GA and business jet ports in the areas as well?
Yeah, that's a great question. We have a really good mix of large and small based on some of our major customers being business jet customers. Business jets fly just about anywhere, so there's a lot of big international airports based on their requirements and other customers, and then there's some of the smaller ones as well. So again, you can get to that information from our website or contact me, and I can get you a KML or a shapefile of the airports that we have in our database. And then if there's some that are of interest to you guys that are listening right now, guys or girls, then we can look at those locations. If we don't have them, we can come up with a way to go get those and populate that data for you. So
So that's going to conclude the Q&A portion for today's webinar. I'd like to thank Hayden again for his wonderful presentation. It's very informative. I hope all of the attendees were able to walk away with some very valuable information today. If you'd like more information, or if you have some follow-up questions that you have for Hayden, I encourage you to reach out to him directly. On the slide is Hayden's email address, as well as the website address for CompassData. For those that are attending the live webinar, inside your chat box, I have copied and pasted Hayden's email address as well as the CompassData website address. So that's going to conclude today's webinar. Once again, I'd like to thank Hayden and for everyone for attending, and we hope to see you at